So, good evening, Shiva. Good evening to everyone. So, here we are with our lecture number 5 on fluid mechanics. Okay, before that, what we have covered is Archimedes' principle and laws of flotation, buoyancy, buoyant force. These all we have discussed in our previous lecture. And also, we have shown some numerical. So, today, what the agenda for today is the equation of continuity and Bernoulli principle. Okay, so these two topics we are going to learn today. It does not mean that only Bernoulli principle is the single topic. Bernoulli principle, to reach out the Bernoulli principle, we must understand the equation of continuity, streamline flow, turbulent flow, and all of the concept. Okay, so also in your class, how many students are there, Shiva? 20. So why they are not joining class, this class? There are 20 students, at least half of it should be joined. Na? Okay, so we will wait. No, we will not wait for a single minute. We will start the lecture. Okay. Any kind of query you have in the previous session? Any kind of query? Shiva, if any kind of doubt you have from the previous session also, you can discuss it. Okay. So equation of continuity and Bernoulli's principle we are going to deal today. What's our learning objective? Firstly, we will deal the streamline and turbulent flow. Okay, we are going to see what is that. Then continuity equation and Bernoulli's principle. After that, we are going to discuss some of the application of Bernoulli's principle, the Venturi meter, dynamic lift, and Torricelli's law. This dynamic lift is also related to the Magnus effect. So that I'm not written here, but we will be discussing it all. Okay. So these topics we have to cover today. Now, streamline and turbulent flow. You know what the flow is? Flow is the property of fluid, that how it is flowing, what path it has been taken. It is flowing smoothly or roughly. Okay. So that is somehow associated to the streamline and turbulent flow. So I'm giving you some idea that if the flow of the liquid is so smooth, then it is said to be a streamline flow. And if the flow is abrupt, not smooth, then it is turned out to be a turbulent flow. Okay. So when you see you have a hose pipe, if you have a hose pipe in your house, you connect it to the pump, and initially, if you will see, if the water is coming out with a less speed, so the flow is very smooth. Okay, but if you somehow change the cross section of it by pressing it, or if the speed of the water is too high, then you will see that water will not come out smoothly. That flow is the turbulent flow. Okay, no, Fluid flow, if I talk about, fluid can be flowed in two ways: streamline, and you will see this. This is the these green lines are the flow of liquid, of fluid, sorry. And these are very, you will see this is very smooth, if you will see. Okay. Again, if you see the flow of this fluid, it is very smooth against this surface. है ना? So fluid flows in the forms of layer in streamline flow. Now, if I talk about turbulent fluid flow, so it is the intermixing of fluid during flow, which means that one layer will mix with the another layer and disturb the flow of both. So this is a kind of example of turbulent flow. You will see that there is no smoothness in this emanation, in this flow of this fluid. Is there any, you will see, na? Is this flow you will say smooth? No. This is a turbulent kind of flow because there is no formation of such kind of layers. Okay. Now, what is streamline flow? So the flow is said to be steady if at any given point the velocity of the each passing particle remain constant with respect to time. I will discuss it with you. What is a streamline flow? So streamline flow, if I discuss you with you, streamline. So it is a smooth flow related to the smoothness of liquid or fluid. Smooth flow. These are some lines which represent the flow of fluid. I am discussing some of the properties of it. Just a second. Yeah. So what is happening in streamline flow? The definition will say that ki in this flow, the velocity, let's say there is a particle here. Let me change the color of the pen. If this is a particle here, okay, and that is another particle which is following this particle. So in streamline flow, the particles of fluid will follow the same path. Follow same path. It does not mean that this fluid element is following this line and this fluid element just adjacent with this element will follow the another curve. No. This is the property of streamline flow, that all the fluid particle will follow the same path, same line, on same line they will flow. In the previous animation, you will see they are flowing in layers. Okay. So the path followed by the particles are same. And one more important point, that if at this point, let's say this point is A, this particle has a velocity V, which is 10 meter per second. So when this particle B will come to this point at point A, this also has the same velocity, 10 meter per second, which means in streamline flow, the velocity of the particle of any point is same as the velocity of its predecessor, उससे आगे वाले पार्टिकल की जो वहां पे वेलोसिटी थी at particular point A, that will be the same velocity of any particle who will cross this position. Okay. जहां पे where the density of this on these lines are greater, which means flow is denser. And here, when the separation between them increases, flow is rarer. Here the velocity is high, velocity is high, and here the velocity is low. If you draw the tangent on this streamline curve at any point, the tangent will give you the direction of flow. Tangent to the streamline curve gives you gives us the direction of flow. Okay, so this is what we have as streamline flow. Got it? I hope you are clear with this. Note it down what I have written, or take the screenshot of it. Hello Shravani, how are you? So this is the streamline flow that we have. We have discussed it. I will revise it for Shravani. That in streamline flow, the flow we will say as streamline, which is smooth. Okay, so the smooth flow of fluid is termed as streamline flow. Also, there is a property that all the particle in streamline flow will follow the same path. Okay, where every point, if this point has a velocity, let's say 10 meter per second, so each and every particle who is crossing this point has the same velocity. Okay, where the fluid lines are denser, we will say that flow is denser. Where the fluid lines have a separation between them, then we say flow is rarer. The velocity is high for the denser point, and velocity is low at the rarer point. Okay, if you draw the tangent to this curve, so tangent to the streamline curve gives you the direction of flow. Got it? Now I think you have understand. You will see when the velocity of particle may change as it move from one point to another point. Like in this diagram, you will see here the velocity direction is this. Here it is in this direction. If you draw it here, it will in this direction, the tangent to this curve. So each and every particle which passes this, the same point, behaves exactly at the previous particle. Okay, that just had passed out. So all of things that I have discussed is written here. No. So streamlines are nothing but the imaginary curves that we would draw. Okay. The tangent on which will give the instant picture of the fluid particle or instant picture of the flow where the fluid is going. This. So these are the representation of streamline. One of the important property of it that streamlines do not cross each other, because if they do so, if they cross each other, so the point of intersection, the fluid have two possibility to flow, and we will never see that fluid will getting confused that in which direction I have to flow. No two direction of flow at particular instant will not be possible. Okay, so that is why it is impossible for a streamline to cross the other streamline. So the challenge is that why two streamlines do not cross each other. I have discussed it with you. If they cross, then fluid has two vectors, velocity vector, which means two possible direction we have here, which is not possible. Now, yeah, smoking is injurious to health, as you all know, and do not ever smoke in your life, because it will just ruin your life and get you to the tremendous, like helpful tremendous results. So do not smoke. Okay. When somebody just light up his cigarette, so the if you will see, the smoke will come out in this manner. This flow of fluid, which is not smooth, you cannot say that this flow is a smooth flow. It is termed as the turbulent flow. It is just at the opposite of the streamline flow. Turbulent flow. So when the fluid particle does not flow in the forms of layer or does not flow smoothly during the fluid flow, there is an intermixing of the fluid layer. The fluid is said to be a turbulent flow. Okay, you can see in this example, this flow you can take at the turbulent flow. Now, what is the factor that will decide that this flow should be a streamline flow or this flow should be a turbulent flow? So there is a number called Reynolds number who will who will tell us that which flow would be a streamline flow and which flow would be a turbulent flow. Okay, and there is one more flow which is termed as transition flow, which is in between when the fluid is transmitting or changing its phase from streamline flow to turbulent flow or turbulent flow to a streamline flow. So the flow in between the transition phase, we have a flow named transition flow in which the fluid is in transition state. Now, so the main basic difference you will keep in your mind that it is happening because of the velocity difference. So if the fluid is flowing very fast, that flow should be a turbulent flow. And if the fluid is flowing at a certain speed, not too fast, at a smooth speed, then it is said to be a streamline flow. You can see in this example, this is a, in this the fluid flow has a less velocity. Here is the velocity is v1, here the velocity is v2, and v1 is less than v2. So we will see that when it strike the boundary, the fluid will not disturb its flow. It again start flowing in layers, means streamline flow will be there. Okay. But what if the fluid is flowing very fast? So you will see that as it strike the boundary, the flow will disturb itself and become the turbulent flow. Got it? This is an example of turbulent flow. Turbulent flow. The velocity is the greater factor in this. Also, the density of the liquid will also play a role. But you will, for now, you will keep in your mind that density of fluid and the velocity of flow will play the role to decide that which kind of flow it was. No, it is going to be. Is it going to be a streamline flow or turbulent flow? Now, at high speed, there are maximum chances of flow to be turbulent. Keep this in mind. Got it? तो यहां तक समझ में आया? Clear? Shiva, Shravani. If any kind of doubt you have, you can just ask. Now, we are dealing with continuity equation. Thank you, Shiva. Continuity equation and Bernoulli's principle. Shravani, you have any kind of doubt? If you have, you can ask. So continuity equation, just to remember, What is a continuity equation? Look, there is a flow of fluid. I will consider a pipe here. Okay. If the cross section of the pipe is same cross section. Let's say I have enter 1 kg water here. So at the outlet, how much water I will receive? Tell me, Shiva. If at the inlet of the pipe, I will give inlet of the pipe, I have give 1 kg of water. So at the outlet, how many kgs of water I will get? 1 kg. Very good. Obviously 1 kg. But if I change the cross section, okay, and I have given here 1 kg of water. So how much water I will receive at the outlet? Is it 1 kg or less? 1 kg. You are missing something here. Obviously, we are going to get 1 kg, but in how many times? That how much time? That is the important factor here. Here the cross section is same, so there is no problem. The liquid enters and gets out with the same speed. But here the cross section has been changed, so we are interested in the mass flow rate, which is mass flow per unit time. Suppose for delta t times, for a time difference of delta t, m mass has been entered in this. So in this delta time t, m mass will be getting out, which means there is no chances of the accumulation of the mass, because you will see if this is the mass m1 at the inlet and here is the m2, if m1 is not equals to m2, which means some of the mass is accumulating here and it will burst out the pipe, and it is not happening because of the conservation of mass is conserved. So the amount of mass you have given here, the same amount you will receive on the outside of the liquid. Got it? And this is we are going to learn in continuity equation, the conservation of mass. Now this is an example. I have a pipe and this is the tap. I have just opened the tap, the fluid will flow at this time. Every one of you will relate to this. We will do it this in daily life. Okay. So as soon as I open the tap, after some time, the fraction of second, the water will come at this end and flowing out. Got it? Now, let's say this range where the water has been dropped is S1. Now, if I just make a thinner cross section than the previous one, or I will just press the pipe that I have in my hand. So what will happen? You will also relate to this. The fluid will now cover more range, which means the velocity of the fluid has been increased. And why it is happening so? Because suppose in this example also, the mass enter here is m1, but this is the bigger cross section. This is lesser cross section. So it will not allow the same mass. So what does the liquid do? Fluid will do what? Fluid will move faster in this cross section so that it can accumulate that amount of charge. That amount of mass. Okay. Got it? Why on pressing this pipe, the fluid flow will increase? Because at the bigger section, I have received a mass m. So to cross that mass for the smaller section, we need to increase the speed so that all the mass that have entered will come out. Got it? Now I'm thinking that you are getting the idea behind it. the fluid flow will increase. Okay. We know that S2 is greater than S1. Why? I have told you already. Now, if this is a pipe of different cross section, the area of this surface is A1, area of this cross section is A2. The fluid enter here with velocity V1, so obviously the velocity is not same. Velocity here is V2. But we know that if in time T1, this liquid, this surface of the liquid will move to this point. So the distance here is V1 into delta T or T. Why? Because we know that S is equals to V upon V into T. So velocity here is V1. Time taken by the fluid is T. So the displacement of this film to reach at this point is V1 into T, which means our fluid has displaced a distance of V1 into T in time T. Similarly here, how much fluid is being displaced? So it will be V2 into T, V2 into T. Now, the continuity state जो equation है states that the rate at which the mass enters in the system is equals to the rate at which the mass leaves the system because of the conservation of mass. Okay, the rate at which the mass enters, it leaves with the same rate, mass flow per unit time. Okay, so dm by dt of entering is equals to dm by dt of leaving. Now we know that it is nothing but mass entered is equals to mass outward, or we will say it mass leaving. So mass is given by what? Density of the fluid into volume of the fluid. Got it? So for it is rho 1 V1, rho 2 V2. Now this volume is given by area into displacement, area into length of that cylinder, rho 2 into A2 D2. Now D1 and D2 we have calculated in terms of velocity and time. So it is rho 1 A1 V1 into T, rho 2 A2 V2 into T. This T and T will cancel out. So we will have with rho 1 A1 V1 is equals to rho 2 A2 V2. Here this V is not volume, it is the velocity. Now if the liquid is incompressible, means you cannot compress the liquid or you are using the same liquid. Okay, so you can say that this rho 1 density at the entering side will be equals to the density of the leaving side. Got it? So this rho 1 is equals to rho 2, so we can cancel it out. So we will have an expression that A1 V1 is equals to A2 V2, which is equals to a constant. A1 V1 here is nothing but the, if you will see, it is area into d by t, volume flow rate, you can say it. Okay, so liquid is incompressible. This you have as a, and this is termed as the equation of continuity. Can you derive it now? Equation of continuity, you will have to take mass entering is equals to mass leaving, and you have to do this way, rho 1 v1, rho 2 v2, and do some mathematics. Got it? This is the equation of continuity. Now you will understand, if you increase the this a1 by a2 is equals to v2 by v1. Now if I have a pipe like this, the area here is a1, it is a2, let's say velocity here is v1 and velocity here is v2. So obviously we know that a1 by a2 is v2 by v1. V2 by V1 is equals to A1 by A2. We know that A1 by A2 is less than 1 because A2 is greater, A1 is less. So A1 by A2 is less than 1. It is A1 by A2, which means V2 by V1 is also less than 1. So V2 is less than V1, which means at smaller cross section we have faster flow of fluid, and at bigger cross section we have slower flow of fluid. So as you compress that pipe, hose pipe which is connected to the tap, the fluid velocity will increase. Okay. Got it? Now, so if a liquid, this is the question, if a liquid enters a pipe of diameter d with a velocity v, what will be its velocity at the exit of the diameter if the diameter reduces to 0.5 d? So we will consider that d1 here is d, and d2 final is compressed, which is or reduced at 0.5 d. Another information that is given, that liquid enters a pipe of diameter d with a velocity v. It means v1 here is v. v2 we need to find out. So we are going to apply the continuity equation. A1 v1 is equals to A2 v2. This is a circular pipe, that is why it is having a diameter. So A1 means cross sectional area of the first surface, which is, you can write it as pi by 4 d1 square. V1 is equals to pi by 4 d2 square into V2. Now pi by 4 and pi by 4 will cancel out. So V1 by V2 is equals to d2 by d1 ka square. Now we know that d2 is nothing but 0.5 d divided by d1 is d square. D and d will cancel out. V1 by V2. V1 we know as V by V2 is equals to 0.25. 0.5 ka square will become 0.25. So V2 we have as V upon 0.25, which automatically, if you remove the this decimal point, it will become 4 times of V, which means as the diameter reduces, the speed will increase. So diameter reduces by half, so speed will increase by 4 times. Got it? Any kind of doubt in this question, Shiva? If you have, you can ask. Okay. No. This kind of question has a tendency to be asked in the question in the examination. Okay. So try to solve this question. Here three areas are given. A1 V1 for this cross section, A2 V2 for this, A3 V3 for this. So we have to calculate the velocity for this. All the required data is given to you. Now, here we will see, we know that equation of continuity, that whatever the mass will enter, the same mass will be leaving. And also in the continuity equation, we know that this product area into velocity is always a constant. Got it? Which means the mass entering this side, and we can relate it with continuity equation, A1 into V1, volume flow rate. A1 into V1 should be equals to this plus this, means A2 into V2 plus A3 into V3. Any doubt? है ना? ऐसे ही होगा ना? I hope you are getting it, Shiva. So say The mass which enters this side, leaving this side and this side. Okay. So all the values we know, only V3 we don't know. So we can calculate it now. Put the value of A1, which is 10 centimeter square. And you have to convert it into meter because velocity is given into meter. So 10 into 10 raised to the power minus 4. V1 is nothing but 5. A2, 3 into 10 raised to the power minus 4. V2 is given as 12. A3, 5 into 10 raised to the power minus 4 into V3. Now this 10 raised to the power minus 4 you can cancel out. It will become 50. 12 3 is a 36 plus 5 V3. Now you will take this side 50 minus 36 is equals to 5 V3. So 50 minus 36 will become what? 14. 5 V3. So V3 will become 14 by 5, which is results in 2.8 meter per second. Okay, got it? So this is how we are going to solve this kind of question. Okay, just by equating their flow rate, velocity with acceleration. The same thing it has been done. Now, this is the pipe that I have taken. Okay, and these pipes are placed at different heights. And also the cross section of these pipes are also different. I have taken out the middle portion of it so that you will observe the flow of it. So if you are able to see the flow of this, you will see at point B the liquid is moving little faster than point A. And it is pretty much understood because the pressure at one end will be high because of two, because P1 is at in the greater depth. P1 is the greater depth. And this P2 is of a less depth if I measure it here. What? No. So the velocity at one end will be less than the velocity of two. Also, the area of cross section at A is greater than the area of cross section at B. So the velocity at cross section A is less than the velocity of cross section at B. Now what will happen? Now we are going to deal with the Bernoulli's principle. You are clear with the equation of continuity? So what does Bernoulli did? Bernoulli just take the equation of continuity. Okay. And equation of continuity tells us about the conservation of mass. So he was wondering that if the mass is conserved, the energy will also be conserved. So he take that continuity equation and apply the work energy theorem, calculate the work done, and equate it with the kinetic energy and potential energy. And he has came out with a beautiful expression which is somehow denoting the conservation of mechanical energy. Okay. So Bernoulli principle said that this principle is given by this scientist, Swiss scientist Daniel Bernoulli. So this principle is based on the energy conservation. Okay. Expression of that is E initial plus whatever the work done we have done is equals to the energy output, which means there is no energy is wasted in this process. Okay. Now we are going to derive the Bernoulli's principle. What the Bernoulli principle is? That at some point, at any point in a fluid flow, the sum of kinetic energy, potential energy, and pressure energy of that fluid is constant, which means the energy of the fluid flowing fluid is constant for a specific point, and that is somehow related to the energy conservation, because any energy conservation says that energy can neither be destroyed nor be lost. Okay, neither be created nor be, it can only change. We are going to derive it now. This is the cross sectional pipe we have taken. Here the cross sectional area is A. This is the earth surface. At earth surface the height of different cross section is given. This cross section is at height h1, this cross section is at height h2. Okay, and the area of cross section is also given, a1 and a2. Here the pressure is p1, and at this point the pressure is p2. The velocity with which the fluid enters in this is v1, and the velocity with which it came out of that particular pipe is v2. Now let's say this is the displacement that fluid has covered, d1 in time delta t. So d1 we can write it as, d1 is nothing but velocity at this cross section into delta t. d2, which is the displacement of this liquid here in the same time, because this here, here the liquid will be pumped by us with a power source. That could be a pump. So pump is pumping the liquid inside it, which means we are the one who done the work here. We have done the work, but this liquid, this inside liquid, will be thrown outside by the previous, by this adjacent liquid it has, because now this time this will gain the kinetic energy. Kinetic energy has been gained. Sorry. And because of this kinetic energy, this layer of the fluid will push the adjacent layer of the fluid and make the fluid to come out. Okay, so now on this side we are not working, on this side the fluid is working. Okay, so keep this in mind. I will use this expression, use this statement. So d2 you will say, d2 here is velocity at this end in delta t time. Now so here the bigger cross section we have, the smaller cross section. This is at a height of h1. This is at a height of h2. This is a1, a2, p1, p2. Okay. In delta t time, let the water will be moved by this point, from this point to this point, and this is said to be d1, which is equals to v1 delta t. Also, the fluid will be outside by the adjacent fluid at same, d2 is equals to v2 into delta t. Okay, so we can say that the volume flow here, the same liquid is flowing. So we can say that according to the equation of continuity. Continuity equation will say that mass flow in is equals to mass flow out. So what is the mass flow in? Is the rho density of the fluid multiply with the volume, and let's say delta V volume has been flown. Delta V is the volume which has been flown. Okay, in delta T time. So we can say that mass flow is nothing but rho into delta V, and it is for same. For this side also it is rho into delta V. Got it? This is from the equation of continuity. So if you talk about the velocity is being changing on this pipe. Now what is the factor that changed the velocity? Velocity came out from the momentum, and momentum is changed by force, which means there is some kind of force that is acting on this pipe, inside the pipe, which is causing this change of velocity. Now if you calculate the force at this end, it will be F1 is equals to pressure at this point into area of this cross section. Now value of P1 is nothing but rho g h1, rho g h1. Now, and we are measuring the height from the ground. F2 will be P2 into A2. P2 will be rho g h2. Now, if you put the values of pressure in this expression, F1 you will have as rho g h1 A1. This is equation number 1. And F2 you will have as rho g h2 into A2. Okay. So these are the two forces we have here. Now, if there are forces in the system, there must be some work has to be done because the liquid is constantly displacing. Okay. So work done by this force will be given by W1, which is equals to force multiplied by the displacement. So W1 here is nothing but F1, which is rho g h1 a1. D1 is V1 into delta T. V1 delta T. And W2 by work done by force F2 is F2 into D2 but minus. Now pay attention why this minus has been come. This minus is come because here on this side the work is done by the system. Work is done by the system. It is very important to note. Okay. And that is why this minus sign has been appear. Minus sign का reason ये. Okay. So W2 will be rho G H2 A2 V2 into delta T. Now net work done will be, work done net is W1 minus W2. Actually it is W1 plus W2, but W2 is minus. So that is why it become W1 minus W2. So you will have rho G H1 A1 V1 delta T minus rho G H2 A2 V2 delta T. Now this V2 delta T is the length, A2 is the area. So this will become the volume. Area into length will become volume. Similarly here, area into this length will become volume, and which is delta V. We have seen it. So rho g h1 is P1. So P1 minus P2, and I have taken this because the volume flow rate is same. So delta V is the volume. We have discussed it in the equation of continuity. Equation of continuity, A1 V1 delta T is equals to A2 V2 delta T. Okay. So the net work done we have as P1 minus P2 into delta V. Now, this work done, we are going to apply the work energy theorem, which results in the that net work done is equals to the change in kinetic energy. Now, we know that the potential energy is also being changed here because the height is being changing. So we will put that the total work done here is equals to the total kinetic energy and total potential energy change. Got it? Because of the energy conservation. Like how much the kinetic energy has been gained, how much the potential energy has been gained, it results in the work done. Because here, if you will see, the kinetic energy is also increasing and potential energy is also increasing from H1 to H2. So there must be some work done is to be there. So we can say that the change in potential energy, change in potential energy. Now we know that delta M mass has to be flown. Let's say the delta M mass has been flown because in the potential energy change, you will see that mgh is the expression. So delta U is equals to delta M, that is the mass flow rate into G into H. Change in mass. Okay. Now for kinetic energy, change in kinetic energy, change in kinetic energy. Delta K is equals to 1 by 2 times delta M V1 square minus 1 by 2 times delta M V2 square. So it is given by 1 by 2 times delta M V1 square minus V2 square. Okay. Now we put them here. The work done external force is equals to the change in potential energy plus change in kinetic energy. The work done here is P1 minus P2 into delta V, and this change here, this delta U is delta M G into H plus this is 1 by 2 times delta M V1 square minus V2 square. Okay. So here, if you will see, this density will be given by delta M divided by delta V. So you can replace this delta M with rho into delta V. Put it here. P1 minus P2 delta V. Delta M you will put rho into delta V GH plus 1 by 2 times. It is not GH. It is H2 minus H1. The difference in height. H2 minus H1 plus rho into delta V, V1 square minus V2 square. This V is different. This is the volume. Okay. So delta V will cancel out. So we will have P1 minus P2 is equals to rho G. Again, I have written the same. Rho G H2 minus H1. H2 minus H1 plus half rho V1 square minus V2 square. Okay. So if you take it minus, you will get it here on this side. It will become P2 minus P1 plus rho G H2 minus H1 plus 1 by 2 times rho V1 square minus V2 square is equals to 0, which means any change of this kinetic energy will result in 0. So if two quantities are same, 2 minus 2 is result into 0. Okay, which means they have the same value. The kinetic energy, the pressure energy, and the potential energy of the system is 0. Okay. So if we take the reference value as 0, H1 is equals to 0, V1 is equals to 0, and P1 is equals to 0. So we will have as P plus rho GH plus 1 by 2 rho V square is equals to 0. Or you can say it a constant. Okay. So this is the expression we have for Bernoulli's equation. Bernoulli's equation. Okay. So we have seen that 4.1 and 4.2, the change in potential energy, change in kinetic energy, and change in pressure energy per unit volume is same. Okay. So this is it from Bernoulli's equation. If you have any kind of doubt in this expression, you will ask. Otherwise, we have done for today. Okay, Shiva. So thank you so much for being attentive. If you have any kind of doubt, you can ask. Okay. Thank you. Thank you so much.